So in the last lesson, we were completely looking at the sampling distributions to make decisions, and now we're actually going to start from statistical measurements and make those same decisions about what a confidence interval would be. So it says using the mean and standard deviation of a sampling distribution to find the confidence interval. In the last lesson, we estimated 95% confidence intervals by cutting 2.5% of the dots off each end of the sampling distribution. As long as the distribution is approximately normal, we can also find the confidence interval by adding and subtracting 2 standard deviations from the mean of the sampling distribution. This is similar to finding the values at a z-score of 2 and -2. So we're going to be using this formula, the mean plus or minus 2 standard deviations. So in this table, we're going to use that formula just to find the confidence intervals, and then we'll talk about what a margin of error is next. So here's my mean and my standard deviation of the sampling distribution. We don't see it. We're going to kind of put that together on a different day. So we're going to take the mean and we're going to subtract 2 standard deviations. So 2 times 0.06, and that's going to give me 0.31. And I'm going to take the mean and add 2 standard deviations, and that's going to give me 0.55. So just using those statistical measurements, my confidence interval is 0.31 to 0.55. Same deal with the next one. I'm just going to write it as a single statement. So my mean plus or minus 2 standard deviations, so 2 times 0.04. So I would do the subtraction. I would just type the subtraction in my calculator, and that would give me 0.59. And if I did the addition, I would get 0.75. So these are the confidence intervals for the data from those two. So that means if we were going to take another sample of the same size from the population with the same proportion, we're 95% sure that it would fall in those intervals. As I said, these are 2 separate situations, but that's the idea. So the margin of error is pretty simple. We use capital E for it. Of a sampling distribution is just the distance from the mean to either side of the confidence interval. So you can imagine, we have a bunch of dots here. Don't bother drawing this. This is a sampling distribution. This looks awful. Let's try again. I'll do this with X's. So we have some data, and we would fill this in, right? And we'd fill in, looks like a normal curve. There might be 1 or 2 outside the sampling distribution, right? But then we cut them off. So our confidence interval, we said, goes from -2 to 2 standard deviations. Okay, so I'm going to erase this. Now the margin of error is just the distance from the mean to either side. So the margin of error is here or here, and you can quickly see that the margin of error is just 1, 2 standard deviations. So to find this calculation called the margin of error, it's really like the margin we go out from the mean is what the definition of it is. We're just doing 2 times the standard deviation. So we're doing 2 times 0.06 here. So the margin of error is 0.12 in that case. And we'll just do an E equals there. I'll erase this arrow. So we get used to that symbol we use. Here the error is 2 times 0.04. So the error is 0.08. Okay, so pretty simple. Margin of error is just 2 standard deviations, how much we go out from the middle to the sides. So we just did that exercise 2. We filled out the table. Now this is kind of like a side note that I think we'll just be able to easily incorporate. It says, so far the sampling distributions we have done have been for sample proportions. A sampling distribution can also show the averages of samples. For example, if the data being collected was the heights of people, a sample mean would be calculated. So I'd get a sample of 10 people, get their heights, and I'd find an average, and that would be my dot versus the percent peach or proportion of peach for each sample instead of a sample proportion. So here we have an example. The average height of students at Saugerties High School is 67 inches. That's about 5'7". 20 randomly selected students were asked their height. the average of this sample was calculated. This process was repeated, so taking these samples of 20 for a total of 100 samples. So that would create a sampling distribution with 100 dots. Then we find that the mean or average of the sampling distribution was 66.7 inches. So from the sampling distribution, if we set up a frequency table, we would get 66.7 for the average in our calculator, and the standard deviation is 1.9. So you'll see like most of our means have been some sort of proportion. This is just an average instead of an average proportion. We're going to find a 95% confidence interval and a margin of error for the sampling distribution. So we do the same exact thing. Confidence interval is mean plus or minus 2 standard deviations. So that is going to be 66.7 plus or minus 2 times 1.9. Type in the subtraction, type in the addition. Our confidence interval, let's dot down there, is going to be 62.9 to 70.5. So as I said, I'm typing in two separate calculations and that gives me those values. Our margin of error is 2 times the standard deviation, so that's the 2 times the 1.9. So from the center at 66.7, we're going out 3.8 in each direction. So these are our two answers, confidence interval and margin of error. On the next page, we're going to see how we can work from a confidence interval back to the other statistics. So here's a summary of our formulas. Confidence interval is mean plus or minus 2 standard deviations. Margin of error E is 2 standard deviations. So given a confidence interval, it's also possible to work backwards to find the mean, the margin of error, and the standard deviation. So here's a sampling distribution, and they're telling me, I can't see it, it has a confidence interval of 0.61 to 0.73. And we're going to find the mean, margin of error, and standard deviation. So first off, it should kind of make sense. The mean has to be in the middle, okay? So to find the mean, it's directly in the middle of the confidence interval. So we're going to find the average, okay? So to find the mean, I'm just going to add the two values in the confidence interval together and divide by 2. So if I take that in my calculator, that gives me 0.67. So my mean is right here, 0.67. I'm going to label it up here. That's my mean. Not perfectly placed, but I'm a little short on time, so I'm not going to move it over. So now to find the margin of error, all we have to do is say, well, how far do we go out here? We could go in either direction, but I'm just going to go to the larger value. So the error is equal to 0.73 minus 0.67. How far do we go from the mean to the side? Which is 0.07. Just like it's 2 standard deviations to get the margin of error, if I want to find the standard deviation, I can just divide the error by 2, right, working backwards. So 0.07 divided by 2, okay, is equal to 0.035. So just to label, we found that this distance, the green distance, is 0.07, and then the standard deviation, which would be half of it, is 0.035. So you can work backwards from the confidence interval. So in this table down here, we're going to try that. We have some information and we're going to find other information. Here I have a mean and a margin of error. I'm going to find my standard deviation first. That should be pretty easy. That's just the margin of error divided by 2. So 4 divided by 2 is 2.0. Now to find my confidence interval, I'm going to work from my mean and standard deviation. I could just also add and subtract the margin of error, but I'm going to do 6.1 plus or minus 2 standard deviations because that's our typical way to do it. I know I'm going a little faster on this. If you need to go back and watch the stuff on the other page of how I calculate this, this ends up being 2.1 to 10.1. The second one, we're starting from the confidence interval and we're working backwards to find the other information. So the first thing I'm going to find is the mean, and the mean is the average of the two sides of the confidence interval. So I add them together and divide by 2. So the mean here is 145. Next, I'm going to calculate my margin of error. So this was the first thing I did. This was going to be the second, and that's going to be the third. Okay, so margin of error, we go from the side of the confidence interval, which is 190, and we subtract the mean. So that's going to give me the error is 45. And then for number 3, okay, we're going to take the margin of error and divide by 2, okay, which is 22.5. So that's our standard deviation.